So we are looking at example number 2 of difference of squares, solving quadratic equations by factoring. So here we have a difference of squares. We can see that our first term isn't a perfect square, and our second term isn't a perfect square. So, but we do have the difference. So we need to look and see if we have a common factor. The 75 I know can be divided by 5, but my 162 can't. 75 can also be divided by 3, so let's see if 192 can be divided by 3. And when we do that, we come up with 64. So we can factor out of here a 3. When I factor out a 3, I'm dividing the 75 by 3. So I'm left with 25 p squared minus 64. All of that equals to 0. Now as we examine this, we can see that our 25, yes, absolutely, it's a perfect square, and 64 is also a perfect square. That allows us to take and factor this as a difference of squares. So we take the square root of the first term, so that's the square root of 25, which is 5, and the square root of p, which is p squared, which is p. And we put that as the first term in both of our factors. Then we take the square root of 64. That's 8. It becomes the second term in our factors. And we know that we're going to create conjugates where by taking and putting one as subtract 8 and the other as plus 8. And that's equal to 0. So now that we've factored our difference of squares, we can take each of our factors and set them equal to 0. So if I have 5p minus 8 and it equals 0, that will give us a 0 in our equation. And if I have 5p plus 8 equals 0, and I solve for p, I also will have the value that creates 0 in my in my equation. So this isn't as straightforward as the other terms that binomials that we have set equal to 0. So let's make sure that we add 8 to both sides. We have 5p is equal to positive 8. Then we divide both sides by 5 to isolate p, and we get p is equal to 8 over 5. Doing the same thing with the second factor, instead of adding 8, we're going to subtract 8 from both sides. That leaves us with 5p equaling negative 8. Again, we divide by 5 to isolate p, and we have negative 8 over 5. The second part of this question asks us to verify our solution. So we have two solutions and we need to verify both of them. We take the function itself and I'm going to do a left side, right side verification. So on the right side we have 0. Here we have 75 p squared minus 192. I'm going to take 75, I'm going to test my first p, positive 8 over 5. So I multiply that by 8 over 5, and I square it and divide it, or subtract that by 192. So we have 75, and we're going to square this, so we have 64 over 25 minus 125. So I have 75 times 64 over 25. So there's a common factor of 25 that I can take out. I have 3 on top and 1 on the bottom. I'm left with 3 times 64 minus 198. Well, 3 times 64 is 190. And I said 198, that's 192. Subtract 192, giving me 0. And so clearly, my left side equals my right side, and so I have verified this solution. Let's use the other solution that we had, or the other roots, negative 8 over 5, and it hopefully we'll see very quickly that we're going to end up with exactly the same situation. So our right side is 0. We have 75p squared minus 192. We substitute in our solution for p. And when we square negative 8 over 25, we come up with 64 over 25 as a positive number, all multiplied by 75, and I guess, again, minus 192. If we calculate that out, we're going to see that we get 0. So again, the left side equals the right side. And I just missed putting the equal sign in there. So now that we've verified our solution, we can say that the roots of the equation are 8 over 5 and negative 8 over 5.